Hey everyone, welcome back, and today let's solve Leetcode problem 2185 titled Counting Words with a Given Prefix. So we're given an array of strings called words and a string pref as our two inputs. So we need to simply return the number of strings in this input array words that have a prefix of pref, right? Which is going to be inputted to us as a string. And a prefix of a string s is defined to be any leading contiguous substring of s, which really means that it has to the string s has to actually start with that prefix. So for example, if we had a string s, let's just take a very simple example. Let's say we had the string s abba. In this case, some possible prefixes of this string would be a, it would be AB, it would be ABB, and it would be the string itself, because technically this string does start with itself. ABBA is actually a leading contiguous substring of this entire input string. Now, something very important to note is that strings like BB or BA would not actually be prefixes of this input string. Now, these two strings are actually substrings of this because, as you can see, they are actually contained consecutively in this input. However, this does not have a prefix of BB or BA because it's not part of the leading characters of this string. As you can see, the first character in this is A. Neither of these strings even start with A, right? And even something like BBA wouldn't be a prefix because, of course, we want it to start with an A, right? We want to start it with an A and have some number of characters after it in that consecutive order that actually helps make this input string start with it. That's how a prefix is literally defined to be, right? So again, AB, and ABB, and ABBA are all prefixes, but BB and BA are not. Rather, they're just substrings of the string because they are contiguous that are actually contained in the string, but this string does not start with these characters or with these substrings. They're not leading substrings in this input. So let's go ahead and look at the examples now that we've kind of understood what exactly a substring really is and what a prefix really is. And so in example 1, we have our input array string words to be pay, attention, practice, and attend. And in this case, our prefix as our string is going to be at, or simply just at. Now, in this case, we have an output of 2. Why? Is because we have exactly 2 different unique words in this input array words that actually have a prefix of at, right? And notice how we're not actually supposed to return the strings themselves in the form of a list or any given data structure like that. We really just simply have to return the number of words in our input array words that have a prefix of pref, which does make it a little bit more simpler because we won't have to actually have, extra data structures like lists or sets, right? We can just use a simple integer here, right? So now let's go ahead and look at why and which 2 strings actually have a prefix of pref. So as you can see, again, we have a output of 2 because exactly 2 words in this input have a prefix of at. In this case, let's look at them in sequential order, kind of like iterating over this input array words, which will be what our solution also consists of, right? So in this case, we see this pay first. Does pay have a substring or a prefix of pref? No, it does not, because at, the substring at, isn't actually a leading substring in pay, right? Now we look at attention. Attention does actually have a prefix of at. Why? Because as you can see, at are the first 2 leading characters, or at is a first initial substring of attention. Now we move on to, and now that we've actually seen one kind of word that has that prefix, we want to increment our counter, which records how many numbers or how many integers, or rather, how many words we've seen like that by 1. Next, we move on to the next character. That would be practice. Practice does not have a prefix of at. Rather, at is not even a substring or a prefix, and so we wouldn't have to do anything there. We'd simply move on to the next iteration. And then we have attend. Attend is actually containing a prefix of at, and so we can increment our counter by 1 again, kind of saying that we've seen one more word that has that property, and effectively just return our counter once we're done iterating through all the words. In this case, that would simply be 2. And for the next example, in example 2, we have our input array words of strings to be Leetcode, when, loops, and success. And in this case, our prefix is code. So let's start with the initial word in this input. We see Leetcode. Code is definitely a substring of Leetcode, as we can see here. It is actually contained in Leetcode, but it is not a leading substring of Leetcode, and so for that reason, code is not a prefix of Leetcode, and so we don't do anything there. We simply move on to the next iteration here. Code, it literally has a larger length than when. There's no way it can be a prefix. We move on to the next iteration. Loops does not have a prefix of code, neither a substring of it, and neither does success. There are no strings in this input array strings that have a prefix of code, and so in that case, we simply just finish iterating through all the words and simply return 0. We never saw a word that actually did have a prefix of pref. So again, notice how we don't have to actually return the words that have that property in a list. Kind of just telling us that we can really only maintain an integer here, kind of telling us that, okay, we probably will have a constant time, pretty efficient memory complexity solution. And as you can see, for the constraints, actually very small, at least relatively. We see that the length of our words is never going to exceed 100, which is pretty small in runtime and memory complexity wise, and neither is the length of our prefix, nor any single length of any single word in our input array words. They're both not going to exceed 100 as well. And also, we're given that the prefix and any word in our input array words is only going to consist of only lowercase English characters, which is good because it really just tells us that we're always going to have valid inputs, and we don't really have to worry about any weird edge cases here where we have inputs like hashtags or numbers or anything invalid like that. So now let's actually get into the code. What is kind of like a quick high-level rundown of how our code is going to really look like? Again, we kind of glossed over it in our example here in example 1, but for a quick kind of like high level rundown here, basically what we're going to be doing is we're literally just going to iterate over this input array words of all the different strings that we have as potential words. If the prefix, or rather if the current word has a prefix of pref, and we can use list slicing to determine that, well then great, we increment our counter by 1, which literally stores the number of words that have pref as a prefix, which is ultimately what we're going to return once we're done returning, or once we're done actually iterating over all the different strings in our input array words. So with that out of the way, let's go ahead and get straight into the code here. So what I'm going to do first is actually initialize my counter. It's going to be initialized to 0, because of course we haven't actually traversed through the input array words yet, and this is kind of like the default value for this integer. Okay. And now I'm actually going to get the length of my prefix string, just for kind of easier list slicing access when we actually check if a word actually has a prefix of pref. So I'm going to store the length of my prefix to actually be an n, right? And it's simply going to be a regular integer. Nothing too special about that. It's really just going to help us for list slicing when, again, we're checking if a word actually has a prefix of pref. So now let's begin iterating over our input array words. So for every I, or words, or I should rather say word, in my input array words, right, simply just iterating through all the words, we have to actually check, does the current word have a prefix of pref? If it does, great, we increment its number or counter by 1 and return the counter at the end. But how do we actually tell if the current word has a prefix of pref? Well, we can use list slicing here. Basically, we have to check, well, from the 0th indices, because again, we want it to be leading for it to be our actual prefix, from index 0 up until the length of the prefix for those indices in that range. If that's actually equal to pref, well then we know it's going to be a prefix. And I'll actually go over back into the examples here to better show this. But basically the way this is going to be coded for list slicing in Python, basically if the current word, and again this is list slicing, from index 0, we don't have to have 0 here because it's a default, it's already implied when we have nothing from the left side of that colon, up until n, which is again going to be the length of pref. I'm not going to do n-1 because it's going to be n exclusive regardless. If that actually does have a prefix of pref, well then we know we can increment our counter by 1 because we've seen one more word that has a prefix of pref and effectively return that counter once we're done iterating through all the different strings in our input array words, or basically once our for loop has actually terminated, right? So before I actually submit this and actually kind of go into the time and space complexity, I want to actually kind of help you guys understand and explore what this list slicing really means and why we're actually comparing it to pref, because that's actually a very important, most kind of difficult line of the solution. Let's go ahead and look back at the examples here. So effectively here we're checking, does word from index 0 up until index n exclusive, does it actually equal the prefix? Well, why are we even caring about the indices in this range? Well, let's go ahead and look back in our input array words. So as you can see, let's take a very simple example here. Let's say we're currently in the iteration of checking attention as our current word. Okay, nice. Well, what would n be in this example? Well, we know that it's always going to be constant for every single test case. It's not going to be changing or anything like that. We know that in this case, the length of our prefix is simply going to be 2 because, of course, we have 2 characters. And so n in this case is going to be 2. So let me actually comment this out. Example input test case here. Basically, this is example 2, by the way. Let me also comment that out for reference there. Basically, as you can see here, n is going to be 2. So n is going to be, rather, I should lowercase that. N is going to be 2. And so we're assuming we already found that pay is not going to have a prefix of pref. Now we're on the next iteration of attention. Well, basically what list slicing would do here in Python is we would start from the 0th indice and go up until the nth indice exclusive. In this case, that would really mean, because n is equal to 2, the second indice exclusive, which is great for us because it accounts for that 0 index kind of overflow there, so we don't have to worry about actually doing n minus 1 because this is already exclusive in the first place, and so it's already going to be n minus 1 without actually having to type that out because n is going to be exclusive for the indice in this case. So effectively, instead of going from index 0 to index n or 0 to index 2, we're going from 0 to index 2 exclusive. So in other words, really just 0 to index 1. Which is, of course, the 2 characters that we want to compare to see if it's a prefix of pref, right? In this case, yes, it is. Because, again, attention from index 0 to index 1 inclusive, which is equal to AT, is actually equal to the prefix AT. And so since we know that does actually have a prefix, well, then let's increment the counter by 1. And you may be wondering, okay, why are we even going up until the length of pref indice? Why does that have to do with pref? Well, let's think about it here. There would be no point to check the first 3 characters or 4 characters because we know our prefix is always going to have a length of pref. And so that basically means that we always have to check the first n characters because, of course, that's going to be the leading prefix for the pref. Because we know that if something has to have a prefix of pref, it has to start with the number of characters that pref does with the actual same characters. We don't care if the next letter is a T or an E or an R. It doesn't matter to us. All we care to see if attention actually does have a prefix of pref is if the first 2 characters are equal to the prefix, because that's the length of the prefix that we're actually checking. All the characters to the right of it don't actually matter because they don't influence the prefix that we want to check for the current word. And so as long as the first 2 characters are actually equal to the second 2 characters of prefix, well then we know it has a prefix of that, right? And basically that's how that's going to work, and that's really it for the code here. It's honestly a pretty simple problem, and as you can see, unless I made any syntax errors here, this should be accepted. And as you can see, this is really just about as efficient as you can get. So for the time and space complexity, for the runtime complexity, of course, this is going to be a big O of n solution. Why? Well, of course, because this is literally just a one-pass solution. We're iterating through every single word in our input array words exactly once to check if it has a prefix of pref. And so this is going to be a linear time runtime complexity. And for the memory complexity, since we don't care about using any auxiliary memory or any extra data structures to store the important words, really, we're only using this extra n and this counter here to store the number of words we've actually seen that has a prefix of pref. We're only using a few integers. And so for that reason, since we're not using any extra data structures, this is not going to grow directly proportionally with the input size. And so this is going to be a big O of 1 or constant time memory or space complexity, right? So for a quick kind of like high-level rundown of how our code actually works, again, once we actually initialize counter to be 0 and n to be length of pref, we're simply iterating through every single word in our input array words, and we're checking if it actually does have a prefix of pref by using list slicing going up until the nth indice. Of course, exclusives are really the n minus 1th indice to actually account for that 0 index property, where n is the length of our input string pref, and if it does actually have a prefix of pref, we increment the counter by 1, indicating that we've seen one more word in our input array words that has a prefix of pref, and effectively returning the counter once we're done, or rather once the for loop is actually done executing, once it terminates, because that would have meant that we've iterated through all the words in our input array words, right? And the counter is going to store the number of words that actually does have a prefix of pref, because again, we're only incrementing it by 1 when we find a word that has a prefix of pref in this conditional here. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.